Welcome to 18 Amazing Space Facts Part 2. As always, sit back, relax, and enjoy the show. Fact 1. Could humans actually survive on Mars with today's technology, or is it all science fiction? You see, right now, we could technically survive on Mars in short bursts, but only in tightly controlled habitats. We already manage similar life support systems aboard the International Space Station, where air, water, and temperature are carefully recycled. So that part is technically possible. We're also starting to unlock Mars itself. The Perseverance rover has shown we can produce oxygen from the Martian atmosphere, a huge step towards future living systems. But the real challenge isn't just survival, it's distance. You see, if something goes seriously wrong, Earth is not a quick backup plan. A rescue mission or critical supplies would take around 6 to 9 months to reach Mars, depending on orbital alignment. There's no fast response option. Even communication isn't instant. Messages between Earth and Mars take around 4 to 24 minutes each way, meaning a question and answer can stretch into nearly an hour or more. So, living in Mars with today's technology means it wouldn't be a home. Instead, it would be a highly dependent outpost. Fact 2. Have you ever wondered what is NASA's most expensive mistake? You see, in 1999, the Mars Climate Orbiter was nearing Mars after a 9-month journey, and everything seemed okay. But here's what went wrong. One engineer team calculated force using metric units, newtons. Another team used imperial units, pounds. Normally, software could catch that, but this time it didn't. This tiny mismatch changed the space trajectory, so instead of entering orbit at a safe distance, it flew far too close to Mars. As it approached the atmosphere, it either burned up or skipped off into space. NASA simply never heard of it again. The cost? Well, only $125 million, lost all because of a simple conversion error. This is one of NASA's most expensive lessons, proving that in space, even a tiny mistake can have huge consequences. Fact 3. What's the fastest things humans have ever built? The record holder is the Parker Solar Probe. It's a NASA spacecraft designed to study the sun up close, flying through its outer atmosphere to understand how it works and why it blasts energy across the solar system. As it dives closer to the sun like anything before it, it uses gravity like a slingshot, reaching speeds over 600,000 kilometers per hour. That's fast enough to go from London to New York in under 30 seconds. And somehow it survives. You see, a powerful heat shield protects it from temperatures that could melt metal. So while everything on Earth feels fast, this probe is in a completely different league, racing around the sun at a record-breaking speed. Fact 4. Hubble wasn't supposed to be up there today, so how did it outlive its own deadline? You see, when the Hubble telescope first launched in 1990, it was supposed to last around 15 years, a solid run, and then retirement. But right after launch, things went horribly wrong. Its mirror had a flaw, and the images came back blurry. For a moment, it looked like one of the most expensive mistakes ever sent into space. So NASA did something bold. They didn't abandon it, they fixed it in orbit. Astronauts flew up on the space shuttle and essentially gave Hubble glasses. And they didn't stop there. Over the years, more missions upgraded its camera, computers, and systems, making it even more powerful than when it first launched. So, instead of fading out after 15 years, Hubble kept evolving, turning a near failure into one of the greatest success stories in space history. Fact 5. NASA built satellites to last just a few years, so how come some of them just keep going and going? Take the Hubble Space Telescope, for example. It was built to last about 15 years, yet it's still working over 30 years later. Or Voyager 1 and Voyager 2, they were meant for a short mission in the 1970s. Now they're in interstellar space and still sending data back to Earth today. Then there's Mars Odyssey, orbiting Mars since 2001, and the Mars Reconnaissance Orbiter, still mapping the planet in incredible details years past its planned mission. Even the Moon Reconnaissance Orbiter is still circling the Moon long after its original timeline. So, what's the secret? Well, engineers just overbuild them. Backup systems, tough materials, and designs that can handle the worst. Fact 6. We sent probes meant to leave the solar system nearly 50 years ago. Why haven't we sent more since? Voyager 1 and Voyager 2 were designed to explore the outer planets and then continue outwards, eventually heading into interstellar space. And they worked. So why not repeat it? Well, first, speed. You see, the Voyagers used gravity assist from giant planets to gain momentum. This planetary alignment only happens about once every 175 years. Without it, you need much more fuel, time, and money to reach the same distances. The next time we can repeat Voyager is between the year 2150 to 2154. Second, priorities. Modern missions often focus on Mars, the Moon, and detailed planetary science closer to home where we get results much faster. And finally, cost and power. Interstellar probes need long batteries and must survive for generations. The Voyagers, for instance, use plutonium, which has around 87.7-year life cycle, whereas now scientists are developing batteries that last hundreds to thousands of years. Fact 7. What would happen if you jumped off the International Space Station but were in a spacesuit? Would you survive? You see, at first, you'd actually be okay. A modern spacesuit gives you oxygen, temperature control, and protection from the vacuum of space. You wouldn't fall straight down either. You'd keep slowly orbiting Earth, slowly drifting away from the station. But here's the problem. Spacesuits don't last forever. Most have about 6 to 8 hours of life support. Without a jetpack or tether, you couldn't get back. Meanwhile, tiny atmospheric drag would slowly put you into lower orbit. That takes time, but your air would run out long before anything else happens. Fact 8. Here's everything the Artemis 2 will do following landing back on Earth. In the first week after the Artemis 2 crew splashes down on Earth, it's not celebration right away. First, they have to go through immediate medical checks. Even though the crew was only in space for around 10 days, doctors want to see how microgravity affected their balance, their blood pressure, and muscles. Then comes debriefs. The crew spend hours describing everything from how the spacecraft handled to how they slept and ate. Every small detail helps prepare for future moon landings. They'll also reunite with their family, but their schedule stays packed. Scientists run experiments, collect samples, and monitor recovery as their body readjusts to gravity. So the first week back isn't vacation, it's more like a pit stop where the astronauts themselves are the experiment. Fact 9. What would actually happen if we made contact with aliens? The truth is, it probably wouldn't be a face-to-face moment. It would start with a signal. A pattern in radio waves may be picked up by projects like the SETI Institute, scanning the sky for anything unnatural. If a signal arrives, scientists would first spend weeks or even years verifying it, because space is noisy and false alarm happens all the time. But if it checked out, the answer wouldn't be answered immediately. The reason? Well, it's because of distance. Even if aliens are real, they could be hundreds or thousands of light years away, meaning any reply would take generations to travel. So contact wouldn't be a conversation, it would be the slowest message exchange in human history. Hey, it's me again. If you're enjoying the show, don't forget to like and subscribe for more. Now, on to the next part. Fact 10. One of the most currently Googled questions around Artemis mission is, why isn't Artemis 2 landing on the moon? You see, the answer is very simple. Artemis 2 is essentially a test flight with humans on board. This mission's main goal is to prove the Orion spacecraft can safely carry astronauts beyond Earth orbit and back. The crew will loop around the moon, testing life support, navigation, and communication in deep space. There's also no lunar lander attached. The landing system includes Starlight HLS is planned for a later mission. Artemis 2 is like a dress rehearsal. If everything works, the next step is Artemis 3, where astronauts are expected to actually land on the moon. Fact 11. Forget about space ice cream. What astronauts are eating in Artemis 2 mission is way more interesting. You see, the crew will choose from nearly 200 foods, including pasta, beef dishes, quiche, and even cookies. Bread is out and tortillas are in because crumbs floating in zero gravity could damage equipment. Most meals arrive freeze-dried, then spring back to life with water, while drinks like coffee and tea come in sealed pouches. Also, there's no fridges, so everything has to last the entire trip around the moon. It's carefully planned to keep astronauts healthy and focused throughout the mission while flying hundreds of thousands of kilometers away from Earth. Fact 12. Have you ever wondered what would happen if we pointed the Hubble Space Telescope at Earth? It sounds simple, but it gets crazy really fast. You see, Hubble is designed for deep space, not a lone planet. If we tried, the images would be blurry beyond recognition. The bright sunlight would fry its camera, and because it's orbiting at 28,000 kilometers per hour, Earth would streak past like a giant glowing blur. Basically, a telescope for galaxies can't handle our own backyard. So next time you see a stunning Hubble image of a nebula, remember it's built for the farthest corner of our universe, not for the streets outside your window. Fact 13. With the upcoming Artemis missions, one of the questions that keeps cropping up is, why haven't humans gone back to the moon in over 50 years? You see, after Apollo 17 in 1972, it wasn't lack of interest the reason why humans didn't go back into the moon, but instead it was a combination of money, politics, and risk. You see, moon missions are insanely expensive, costing billions per trip. Plus, Earth had bigger priorities at the time, like space stations, satellites, and Mars dreams. And let's not forget, the moon is a dangerous place with radiation, craters, and no air to hide behind. But now, with private companies and NASA Artemis programs, humanity are prepared once again to step foot on the moon. Fact 14. Ever seen a giant cosmic eye staring back at you? That's the Helix Nebula, and it's not just beautiful, it's the death of a star captured in stunning detail. This nebula 700 light years away is what's left after a star like our sun sheds its outer layer. Those glowing rings, they're gases heated by the dying star's core, creating the eerie eye-like swirl you see today. Astronomers call it the Eye of God because it feels like the universe is watching us. And the crazy part, in a few tens of thousands of years, all of this will fade away completely. But this snapshot gives us a peek at the life cycle of a star and the beauty that follows. Fact 15. Have you ever wondered why does the moon look white in the night sky? You see, the moon itself isn't actually bright white. It's mostly grey and covered in rocky dust called regolith. Its surface reflects sunlight, and because the space around it is so dark, it appears bright to our eyes. The whiteness we see is also affected by how our eyes perceive contrast. Against the pitch black sky, even the grey rocks looks almost glowing. Sometimes the moon can also look yellow, orange, or red, like during a lunar eclipse or when it's low in the horizon. That's due to the Earth's atmosphere scattering sunlight similar to a sunset. So the moon isn't naturally white, it just reflects sunlight and tricks our eyes into thinking it is. Fact 16. What would happen if Earth spun twice as fast as it does today? First, our days would only be 12 hours long instead of 24 today. Sunrise, sunset, and night would flash by in half of the time it does today. The faster rotation would also change gravity at the equator. You'd feel slightly lighter because centrifugal force would push outward, and oceans would bulge more, affecting the cities around the equator. And oceans would bulge more, creating stronger tides and bigger waves. Weather would also go wild. Winds would speed up dramatically, storms would be more intense, and the atmosphere circulation would shift. Life on Earth would have to adapt to shorter days, faster tides, and stronger winds. Even the way we measure time, sleep, and work would have to be completely different. Fact 17. Take a look at the solar system diagram behind me. Which planet do you think is the hottest? Most people would think Mercury, being the closest planet to the sun, would be the hottest, but they would actually be wrong. The real heat champion is Venus. Why? Well, you see, Venus has a thick atmosphere made mostly of carbon dioxide. This traps heat in a massive runaway greenhouse effect, like the ultimate planetary oven. Mercury, on the other hand, has no atmosphere, so while it gets scorching hot during the day, it cools drastically at night. Venus, on the other hand, with its thick atmosphere, stays insanely hot 24/7. Fact 18. How do we know our galaxy, the Milky Way, is rotating? You see, astronomers watch the stars and notice something strange. You see, stars on one side of the sky move towards us, while stars on the opposite side move away. That's exactly what you'd expect if everything is spinning like a giant cosmic carousel. They also measured tiny color changes in starlight. Some stars shift slightly blue, others slightly red. That only happens when objects are moving in opposite directions. Put it all together and the answer is wild. Our galaxy, the Milky Way, is rotating. And the sun, alongside you, is rotating around the center at around 828,000 kilometers per hour.